All right, welcome to day one. Continuing with our quadratics unit here. So we have 9.1 using factoring to solve quadratics. And for our warm-up, we're going to take a look at what happens. We're going to try to solve these two equations. That is not the pen we want. All right, so number one, starting with an equation C times D equals 0. Okay, and what we're going to notice is that in order for this to be true, right, either C has to equal 0 or D has to equal 0. It's going to be one of those two. Okay, right? Because if I multiply 3 times 0, I get 0, or it's 0 times 3. So either C 0, D 0, they both could be 0. So the same thing is going to apply here. In order, if it's C minus 5 times D equals 0, either this is 0, right, or this is 0, or they're both. Okay, and so what we would say is, in order for C minus 5 to equal 0, we would have to plug in 5 for C. So we know that C has to equal 5, or, right, the other option is if D is equal to 0, then it's just 0. Okay, this property is called the zero product property. So what it says is, if we're multiplying two numbers and they equal 0, then either A is equal to 0, B is equal to 0, or both A and B are both 0. So when we're solving an equation and we get to our two factors here, what we're essentially going to do is treat each factor like it could be 0. So we're going to say, in order for this 2x minus 1 to equal 0, what would we have to plug in for x in order to make this true? And so we would just solve this equation that's left over. So here I'd add 1 to both sides, okay? And then I'd get 2x is equal to 1, and I divide by 2, and I end up with x equaling a half. And so if I plug a half in for x, and all right, 2 times a half is 1, 1 minus 1 is 0. Or, this is the key, that there's an or there, x plus 3 is equal to 0. And then if I subtract 3 from both sides, I'm going to get x is equal to negative 3. Okay, and so we're going to do a set notation. We're going to say it's a set of 1/2 or negative 3. So likewise, in the same instance with number 2, we have 3 factors. So we're treating each one like, in order for this to equal 0, either the first one 0, the second one 0, the third one 0, or they all could be 0. Okay, so we're going to set each of those factors equal to 0 and then solve. So here, if we have t minus 4 is equal to 0, we know we're going to add 4 to both sides. We could get t is equal to 4. Or 3t plus 1 is equal to 0. So I'll subtract 1 from both sides. 3t is equal to negative 1. Divide by 3, and t is equal to negative 1/3. Or, right, I can have t plus 2 equals to 0, and then we move that 2 over, and I'm going to get t is equal to negative 2. I don't know why we made a 3 there, but negative 2. So our solution set is going to be the numbers 4, negative 1/3, right, or negative 2. And so what we're going to get into is taking an actual quadratic equation, like number 1, and solve by factoring. Okay, so step number 1, you got to remember, is to get it in standard form. So get, I'm going to type here to make it easier for us. All right, so get the equation equal to 0 and in standard form. Okay, kind of the same thing we're saying here. So remember, we want this to look like 0 equals ax squared plus bx plus c. All right. Second thing we're going to do, we are going to factor completely. Remember to use your checklist here. Remember the checklist, GCF, and how many factors. So 2 factors are perfect squares, 3 factors is a trinomial, okay? And then after you factor, make sure you check each factor again, okay? Once we get our factors, we're going to set each factor equal to 0. That's our zero product property, right? Step number 4, we're going to solve for x, all right? For each factor, we got to solve for x. And then the last one, we're going to state the solution set. So that is our process here, procedure for factoring. All right, so take a look at number 1. We're going to factor completely. So remember, if we use our diamond, why does it keep doing that? If we use our diamond here, okay, we know we want to multiply to give me 2 and add to 3. And so I'm going to use the numbers 1 and 2. So I'm going to do y plus 1 times y plus 2 is equal to 0. Then I'm going to do my zero product property. So either y plus 1 is equal to 0 or y plus 2 is equal to 0. Okay? Now you can show your minus 1 each side. You should hopefully be able to tell that we're just going to subtract 1 from both sides. All right? And get an answer of -1. Or we're going to move the 2 over by subtracting that from both sides and get y is equal to -2. So those are 2 solutions. We're going to throw our solution set down. So -1, comma -2. And there's our answer. Okay, number 2. All right, we want to get it in standard form. So technically that's negative n squared plus 13n is equal to 0. And then we're going to say to ourselves, self checklist for factoring. GCF first. And I totally forgot to bring the n in here. Okay. You might also want to leave this, in this specific case, as 13n minus n squared. I did it again. You can do the GCF here too. It'll work either way as we go along. But GCF is an n, so I'll take an n out, and I have minus n plus 13 left, and then I'm just going to solve each of these. So this factor is just n. So when I set it equal to 0, I'm done. N is equal to 0 is one possible solution. Or if negative n plus 13 is equal to 0, here I'm going to add n to both sides, so I can just make n positive. And I'll have n is equal to, we can kind of flip it around, right? That n is equal to 13 here. So my 2 solutions are 0 and then 13. All right. So we go to the next one, right? You might think to yourself, oh, there's a GCF here. But remember, we have to get this equal to 0 first. There's not an 18 product property, right? It's a 0 product property. You got to get it equal to 0. So I move the 18 over by subtracting. I'm going to put it in standard form. So 6r squared minus 12r minus 18 is equal to 0. And if you were thinking about not like doing this the way we'd see like, oh, look, there's a 6 in front, so I have to use that diamond thing and like 6 times 18, you're like, man, this is going to get crazy. The reason you're getting crazy is because you didn't use your checklist. There's a GCF here, guys. GCF factoring is going to make everything easier. You're making all the numbers smaller. It'll be easier to factor. So we take the 6 out, which leaves us with r squared minus 12r. Nope, not 12, 2r minus 3. Okay, now we have to check the inside here, and we see that this does factor again. It's 3 terms, so it's a trinomial. Multiply to -3, add the -2 is -3 and 1. So now I'm going to include the 6 here because it has to stay with the factor. And then it's r minus 3 and r plus 1. I can't factor either of those again. Okay, so we're going to move on to our next step, which is to do, I'm trying to fix that 3 there, but making it worse, is we're going to do our zero product property. Now the first factor is 6. So we're going to say the 6 equals 0, and no, it doesn't. So we're going to do the not equal sign, and then this factor is essentially gone. So that solution can't be 6. because 6 can't equal 0. We're done with that one, okay? Or we're going to get r minus 3 is equal to 0, which in that case means that r has to equal 3. Or we get r plus 1 is equal to 0, which in that case means r is equal to negative 1. So the solutions are not 6, but just 3 and then negative 1. Okay, so if there's a GCF up front, we're going to set it equal to 0, but remember in that case it can't equal 0, so that solution is then done. Okay, number 4, same thing here. GCF first, there's a 4, and that leaves us with x squared minus 9 equal to 0. Okay, it was already in standard form and equal to 0. Then I check, I can factor the inside again. It's 2 terms, that's a difference of perfect squares. So it's x plus 3 and x minus 3. And then we do our factors. So equal to 0, or x plus 3 is equal to 0, or x minus 3 equals 0. And then I'm going to go ahead and solve. So this one, remember, can't be true. In this case, x is equal to negative 3, or in this case, x is equal to 3. Then my 2 solutions are negative 3 and 3. All right. Number 5, a little bit tougher, right? But remember the rule, I have to get this equal to 0, okay? So I'm going to go ahead and distribute the x through first. So x squared plus 5x is equal to 5x plus 16. Now I'm going to get everything on one side and equal to 0. The key thing is this. I always want to keep the x squared positive. So if the x squared is positive and it's on that side, then everything's coming over here. If the x squared was negative, okay, then I would want to move everything over here and make the x squared positive. So always keep the x squared positive, okay? You want to get it positive and keep it positive. So here we can see in number 6, I'm looking into the future here. This is negative, so I'm going to want to make it positive by moving everything that way. Or, I'll show you another trick in a minute here, okay? But keep that in mind. So I'm going to move the 5x over, okay, which means these 5x's are actually going to cancel. And in the same step, I'm going to move that 16 over, okay? These ones are going to cancel. Now, if it's making you confused, then just move them over one at a time. So these are gone. I get x squared equals 16. I'm going to move the 16 over. I get x squared minus 16 is equal to 0. And then I do my factoring. No GCF, but there is perfect squares. So it's x plus 4, x minus 4. Then we do our 0 product property. Okay. And then we end up with our answers. So either x is going to equal negative 4. We already have the or there. Or x is going to equal 4. And then we have our solution set. So it's negative 4 or positive 4. Now, another way to write this, negative 4 or positive 4, is to use with plus minus sign. So if you see this written, this means the same thing as this. One answer is positive and one answer is negative. Just in case you see that anywhere, you kind of get the idea of what that means. All right. For number 6, we're going to do the same thing. We mentioned before, I need to move this to the other side. So either I can move all 3 terms at once, or another way to change signs is to divide everything by a negative 1. So if I divide this side by a negative 1 and this side by a negative 1, this will change all the signs, okay? Remember, a negative divided by negative becomes positive, negative divided by negative becomes positive, positive 20 divided by negative becomes negative 20. And 0 divided by anything is still 0, okay? So now I know I'm looking for 2 numbers that multiply to negative 20 would give me positive 9, okay? And so we're going to ask ourselves, is there a set of numbers here? The answer is no. Gotta have different signs and they not going to get 9. So what we're going to do is we're going to play a game called change that question. So let's make this positive sign a negative sign. So this becomes positive 20. So if this is positive 20 and 9, okay, we're going to end up with 5 and 4. Okay. If it's negative, there's no way for the numbers that multiply to 20, 20 and 1, right? 10 and 2, or 5 and 4 to essentially give me -9 from those numbers. Unless they're both negative, but that makes a 20 positive, so that doesn't work. So we're going to switch to side, changing the question here, people. All right. And then I'm going to go ahead and do my two factors. So we have x plus 5 is equal times x plus 4 is equal to 0. Okay. So here, x plus 5 is equal to 0, or x plus 4 is equal to 0, which in this case, x is going to have to equal -5, or x is going to equal -4. Throw down our solution set, and we're good. All right, try these next two on your own. See what you can do. A little bit tougher. Remember that for this instance here, okay, why does that keep doing that? Stop it. For the first one, we can't write this. It's not x squared minus 25, okay? So another way to think about this before you move on is that this is x minus 5 times x minus 5, and then minus 4. So see if you can do this one. Try number 8. All right, pause it, do it, and then watch the video and see what you get here, okay? Seriously, pause it. Pause it. Okay, here we go. So we're going to just start by distributing. So remember, we get x squared minus 5x, another minus 5x, and then plus 25. We had a minus 4 here already, so we're going to bring that with us. And now we're going to combine like terms. So this is x squared minus 10x in the middle plus 21 is equal to 0. So remember, positive, same sign, both negative. And I need to get -10 out of this. So if you want to use the diamond, you can. So I need -21, positive 21, I should say, and then -10. So the only way for that to happen is -7 and -3. So x minus 7, x minus 3. Okay. We're going to do our zero product property here. I forgot the equal 0 on the first one. All right. Which means either x is 7 or x is equal to 3. And then we have our solution set. All right. And then number 8, this is where the GCF is not. There's no GCF. And I do have a coefficient here, so we're going to do our factor by grouping. Okay, so 5 times 7 is -35. We want to add or subtract, give me 2. So that's going to be +7 and -5. So we're going to switch that 2 in the middle, right, into +7x minus 5x. All right. And then we're going to do our factor by grouping here. So first thing we're going to do is take a 7 out of the first two terms. So 7. And that leaves us with an x plus, I lied, it's not 7, it's 7x. And that leaves us with, now time out. I made the mistake. Let's talk about how I knew that was a mistake. Because I ended up with x squared plus x left over, and I noticed that I still had a GCF here. I shouldn't have anything in common when I'm done. So that's how I knew this was 7x. And that leaves me with x plus 1 left over. Now there's a minus sign in between, so I'm going to keep it there. And then I'm doing the second two terms, which is a 5. And remember, we have to change the signs, so this is x plus 1 again. Okay, so our two factors are the inside guys, the guys in the parentheses, which is x plus 1, and the guys outside the parentheses, which is 7x minus 5. All right, and then once again, zero product property. And then we solve. This is nice and easy. That's -1. Here we're going to add 5 to both sides. So we get 7x is equal to 5. And then we divide by 7. X is equal to 5/7. And then we're going to do our solution set. So we'll just put it off to the side here. And we have our answers. All right. Last question below, Quinn looked at the solution and says that since it's factored, right, we can just do this. And so can you catch the solution? Why is Quinn wrong? Do you see it? Hopefully, you're yelling at me that there's a 2 here and it's supposed to be a 0. Okay? So the correct way to solve this, we actually have to take all this stuff and multiply it back together again. Okay? So I got to take x minus 5 times x minus 6 and do the Humpty Dumpty and put it all back together here. Okay? So distribute x squared minus 6x minus 5x plus 30. I'm going to add the 2 to both sides and combine like terms. Watch out now. Minus 11x plus 32 is equal to 0. Then I'm looking for the factors of 32. That add or subtract to give me negative 11. It's a positive 32, so we know they're both the same sign, and it's a negative 11. They have to be the same thing. So what multiplies to give me negative 32 that adds or subtracts to 11? And you may be saying to yourself, nothing. And you know why? That's because we did something wrong here. So we want to backtrack. Notice that this is plus 2, right? And this is supposed to be a minus 2, Mr. Z. So we know that this is not actually 32, right? But is instead 28. Now you might make these mistakes. So if you find a number, like we did here, that doesn't factor, you got to go back and check your work and see, I had to have done something wrong. So walk back through your steps here, okay? So this should be 28. So now this is making a little bit more sense. Multiplies to positive 28, negative 11, that's negative 7 and negative 4. Okay, so now I do my factoring. X minus 7, x minus 4 is equal to 0. This is referred to, by the way, okay, as the factored form. Okay, so if we hear you talk about this, this is the factored form. Okay, so this is after we factored it out. Remember the original, this guy right here, is our standard form. So you kind of know the difference between them, just when we're talking about it. All right, so then I'm going to do my 0 product property here, so the OR, and then my two solutions are going to be either 7 or 4, and there is my, what are we throwing a negative down there? Solution set. Okay, so you guys have your Nearpod up, so make sure you guys finish that off for the day, and then enjoy the rest of the day, guys.